And I've got this big forging. This is a 4340 forging that I had left over from another job. And what we're going to do is we're going to prepare this for cutting those anvils I had spoke about earlier in another video. We're going to be able to get two smaller anvils, which were roughly about 40 pounds a piece, 45 pounds I think, and then we should be able to get the one bigger anvil that would be 275 pounds out of this block of material. This block is probably roughly around 750 pounds or a little more than that of material here. It's just a forging that was left over from a job a long time ago that I still have. And I got it sitting on these 246 blocks, as you can see, 3 of them with these ball bearings, these 1-inch ball bearings on them. And then I've got this jack stand under here to kind of put a little pressure on here, because this raw forging, there's nothing flat or level about it. And so it really won't set on 4 points all by itself. So I got it kind of setting on 3, and then I put that jack stand and took a tension after I clamped it all down on there. And I've already faced this one side here off, and I got it cleaned up good enough that the corners don't clean up here. It's really not critical, because the anvil, the point, you know, it's got horns on both ends, so it does need to clean up in the middle here, but not in, you know, across here. Needs to clean up in the middle, but the ends not really too critical at this point. And we just got to see here how big the block ends up, because I was thinking 22 inches by 15 inches deep and 8 inches tall, but I don't think it'll quite clean up to that now that I've been measuring it a little bit. And so we're going to square it up first, and then we can go over to the CAD and kind of adjust things a little bit so that we can get our parts out of the biggest block possible, if you will. So right now like I said, I skimmed off that face. We got to turn this thing 180. So, and that's, I don't know if you can hear that noise from that spindle, that whine. So we got to go over here to our if I could hit the right key, our part setup. And this, we got to change this angle. This is the current B0, where the part's sort of indicated in fairly straight, and we got to change this by 180. So we got to change setting number 44 down here. And we got to make that 90.3 and push input down here. And that changed this setting to 90.3. So now we can run the little MDI that I've got stored in here, which brings it to the new 0 point. So it's going to bring G54, unclamp the B-axis and bring it back to 0, that we change the new 0 point. So let's kind of enter that. Then I got to push cycle start here. And we'll rotate back around. Now that's our new 0 parallel to the backside, so we can face both of these faces parallel to each other. And then we're going to take the block and stand it up on one of those faces and clamp it down and face the two, the top and bottom in this case, the big faces of the block, and get them cleaned up to whatever thickness. And then, like I said, we'll go to the CAD software and we'll see where we're at. I'm going to index the inserts. The forged surface, it kind of wipes out the inserts a lot of times, that I guess that scale on the surface. I don't really have the part held good enough the way I'm holding it right at the moment to just take a deep enough cut to get underneath that. Alright, we're going to take about 5/1000ths more off just to clean it up, you know, as a finish pass, if you will. Getting a little bit of vibration here when I was taking those. The depth of cut was 100/1000ths, 500 RPM, 20 inches per minute feed rate. I'm going to bump it up to 600 RPM. I'm going to leave the feed rate about the same. We ended up. Wow, we're maybe just a hair under 15 inches. Not much, just a very little bit on the height right now, according to the tape measure. Pretty close. It might be almost 15 inches that way. We got about 22¼ inches on the edge here. See out in the middle. 22 3/8 there. Over on this side, a little bit less, about 22 3/16 on there. But the ends of the forging are not really super square, it looks like. So I don't know on the length, we'll see. On the height, the way it's sitting here, that measures 8 5/16 maybe. In the middle here, a good 8½. And out on this end, about 8 5/16. So we might come close to the size I needed that I drew in the CAD model, because I drew 15 by 22 by 8 inches. I think the 8 inches will clean up fine. The length, we'll see. It depends on how square these ends are on the forging. So now I've got to clean up all this mess here, all of this, and we're going to set the part. We're going to set, well, let me undo this here. We're going to set the part on this face, on these blocks, in such a way that it is pretty stable. Put these 2 clamp bars on top and clamp it down real solid in the middle of the pallet. I guess I should explain something here as well. The reason I set parts on these blocks on top of the pallet is because this spindle face is almost 12 inches in diameter. It's a little bit less, it's 11 inches something. And you'll hit the top of the pallet or the table with the bottom of this spindle if your tool is not long enough to reach the part, if you will. In fact, you can see right here, before I even owned this machine, somebody already did this. And it's pretty easy to do if you're not paying attention. And so you have to set it on something. And in the case of what we're going to do here, because we're going to face the height with it setting on this face, tipped up on edge, I guess. And we're going to face it to 8 inches thick. But the machine itself, with this spindle face, will only come down to 9 inches from center line of this rotary B-axis table. So if you got 4 inches or half the width of the part here, your tool would have to be a minimum of 5 inches long to even reach the part where you want to machine. This tool is about 7, I think it's a little less than 7 3/4 of an inch from here to here, so the tool is long enough, but you would be hitting the pallet on the bottom of this spindle if you don't have it up on some kind of blocks like this. So that's the reason I do that to begin with. It may have cleared here, I don't know. Let's just see, this would be 7. Now see, it would have even hit there because it's about 8 inches to the edge of that pallet, so it would have been close. It probably would have hit. So I thought I'd explain that because you might have been wondering, why do I even set it up on those blocks like that? And that's the reason, because it'll hit the the bottom of the spindle if you don't. So let me clean up all this mess here, get these shavings out, and we'll run the pallet out, and we'll unclamp it and turn it up on the edge and bring it back in, and then we're going to make some programs, because that's too much jogging and too much likelihood of making a Mr. Bozo mistake going back and forth. So we're going to make a program to face, and once we establish one face, we can run it, index at 180 like we did here, and then do the other side and get it down to the 8-inch thickness that I'm looking for. Okay, I'm going by where I can see where it was setting on the ball bearing here. So I'm making that roughly 0, and over here you can see it was setting, well, maybe you can see it down here. If I tilt the camera up a little bit, you might be able to see the other ball bearing mark here. So I'm roughly going by get it sort of straight. Well, actually, let me do this. Okay, that's really not too bad. Okay, actually that's about right. I think we're going to leave it there. And then we're just going to have to face this till it more or less cleans up. It doesn't have to 100% clean up either. If it cleans up like in this area and across here, but it doesn't clean up in that corner, we can make this. Let me get the camera back on. We can make this the bottom of the anvil, so we don't need this material over here. And the small anvils, the bases are only about this wide that are doing on each end. So as long as if it doesn't clean up in this corner or these corners, maybe a little bit, it doesn't matter. That's not that critical. Hopefully the other side, we'll take this till it gets close to that. And as long as we clean up in this, you know, everything but this corner here, and maybe this, everything else will be all right for the purpose of what we're doing here. And then the other side, we'll take it down to the 8-inch thickness and see what happens. And we should be clear of our blocks right at the moment, because I think I had even if I took it down to this is like 0 on the indicator down here, and if I look at this, that's clearing the block there. And it appears to be clearing the block there, so we'll be okay there. All right. We're going to go to the tool setup. We're going to go 44. We're going to set it at 270.399. So enter 44 here, right here, 44. Tab over to 270.399 input, and that should change that number to that. Okay, that's going to be our B0 for the first side, and then we'll just subtract 180 degrees off of that to be 90.399 for the other side. Okay, we're going to get a rough center on this thing. In X. It's not super darn critical because we're going to actually we got 22.5, so we want to be at 11 1/4. See if we can probe the center line. battery might be dead. Let me see. I think the battery's dead. I gotta change the battery. These older style probes take a 9-volt battery. Kind of spring loaded here, so you have to pinch it together. Takes this kind of a battery. This way. It'd be a little easier if I had the proper Allen tool to do it with. Now you see the lights flashing. I don't know if you can see that. Before it was not flashing. Sort of close here. It's going to give us, it's not going to give us a real good, you know, just a center point. We're going to set our Y0 up here, and then we're going to calculate it down to the center here. Remember, it's 15 inches wide, so we're going to set it down manually in the offset. Our low spot was somewhere over here, so we're going to set the Z0 there, but then we're going to set it out, because there was almost in the middle here, there was almost like right down here in the middle over here, there was like almost 300 thousandths or 250 thousandths coming off. So we'll set it out for the first pass and see where we're at, but we're going to set it there for right now. Now I'm going to change the tool out of the spindle. This thing stays on as long as it's in the spindle. Okay, let's take a quick look at the program in the CAM software. This is this free CAM. It's what I use to program with. So with the roughing cut, I just made a feature that was 15 inches tall and 23 inches wide, just to give me some clearance on the cut on the ends, so I didn't run into anything. And it's just a facing cut, so we're going to face with a we zoom in on this, we're going to face just 120 thousandths deep with this program, and then we're going to keep offsetting it in Z to get to the depth we want, so we don't cut a bunch of air, because you saw how irregular the face of the forging was. So we're going to use a feed mill to do this first facing cut, and then we're going to have finish with that ISCAR heliquad like we were using before. Let me just run through the simulation so you can see it. So the first pass is 65 thousandths up in Z, and the next pass of the feed mill is 10 thousandths up in Z, and then we got the finished face cut at Z0. So that's the program. Very simple program, just so we don't have to jog it around. And to give you the figures, the feed mill is going to run at 600 RPM and 60 inches per minute, and the finished face tool is going to run at 700 RPM and 21 inches per minute. So that's just a quick look at the program so you can see what's happening. The Z, let's move it out. Cancel 0.25. We're going to move it out 1/4 of an inch to start with, to be safe, just to be kind of safe, if you will. All right, so we should be sort of ready to start. All 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 160 Down another 120, I think, and stop there for this side. Seems like right that corner right there is the maximum. So I'll set my zero here with the probe and go in my first 120 thousandths. I think I'm going to index the inserts. They're a little bit, they probably do it, but I'm going to index them just to be safe. I think we're going to call it the end of the first video on these anvils. The next one we're going to look into how we're going to rough these out of the block and split them apart. So if you've made it this far in the video, thanks for watching, and we'll see you on the next video.